Hi friends, today we are going to solve the problem example 2 only. This is related to class 10th chapter 1 real numbers. Show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1 where q is some integer. Here the two types of numbers we need to prove, that is positive even integer, positive odd integer. Even integers are in the form of 2q and odd integers are in the form of 2q plus 1 we need to show. So this one also we can prove by using Euclid's division lemma. What lemma there says? So given positive integers a and b, there exist ineq integers q and r satisfying a equals to bq plus r. So to solve using our Euclid's division lemma, we required first two numbers. For those two numbers we can get two more numbers again. So in the question only we will get some clues. Every even positive integer, right? So let that positive even integer be a. Okay, it should be or in each form it should be in the form of 2q. So when you compare this 2q with our Euclid's division lemma, a equals to bq plus r. At the place of b, what is there? 2. So we can consider even positive integer a and b equals to 2. So we got a and 2 things. So these two things have two more things. Two friends having two more friends. Then the four friends relationship is like this. A equals to bq plus r, like that. So what are those? Q and r. But what is the relationship between r and b? The r is less than always b, greater than or equals to 0. So here b is what? B is taken as a 2. So r will be less than b, means it may be 0 or 1. Okay. So when you apply, the remainder will be 0 or 1. So we got four things here. These are the basic two things, a and 2. We got two more things, quotient and remainders. So remainders are 2, we are getting 0 and 1. So we can use case 1 when remainder r equals to 0. So what will happen? Or this one, a equals to 2q plus 0. Okay. And case 2, what will happen? Case 2, when r equals to 1. When you apply Euclid's lemma for a and 2, q and 1, becomes a equals to 2q plus 1. Okay. Now this becomes a equals to 2q. So this is the multiples of 2, means a is always what? Even number. So we can say even numbers are in the form of 2q. Here multiples of 2 plus 1, you will get always what? Odd number. So we can say all odd numbers are in the form of a equals to 2q plus 1. That's it. Okay guys, I hope you understood this concept. So whatever it may be, questions like this to show any positive integers or odd integers in the form of something like this algebraic expressions, we need to take this number as a b and this is as a, and remainders will be less than this 2. So in this case, when b equals to 2, remainders will be 0 and 1. So when remainder are equals to 0, our our lemma, apply the lemma for, then it becomes like this, and simplify things like this, we will get the solution. Okay, thank you guys, bye, have a nice day.